Good afternoon, Putala. Just finished the lecture, that's why I got late for your one. Still that one is in recording. How about your lecture? Just finished or are there students yet to join? Do you have lecture from 1:30 to 3:30? That's what I'm having. Yeah. Mechatronics, yes. Manufacturing, yes. Even I think BST may be joined the same. Good. Today, lesson 7. Thermodynamics, 202 B2 semester 2. Welcome all the 3 batches, manufacturing, mechatronics, and VST. And today is 29 January 2022. So I'm starting from a previous slide here. Okay. But I'm looking in a different way. So here work done on the mass F times T. Okay. Now let's say, if we think not on the force, but on the mass, I'm rewriting this. Work received by the mass. Okay. Work received by the mass. Of course, work done, received by the mass. Think that from the mass side, work received by the mass, or work done, received by the mass. FD, F times T. Okay, so results kinetic energy increase. Okay, so work done. So I just take only this one. When the mass received, the work done. So it happens to be F times D, the force times. Force on the mass times the displacement of the mass. Of course, in dynamics, force and displacement all are vectors. So you may be learning about this in different way, but this is the simplest way I'm explaining. So when mass receives a work done because of an influence of a force, the mass displaced. Not only that, the important part is the mass receives a momentum change. So mass will get a momentum change, but anyway, displaced. Now let's say, my point is, the same way, instead of a work done received by this nature of mass, I'm thinking of a gas quantity. I'll take from here. Because with that force, finally, with that force, what it receives is a work. So I will go for one more slide here. So this mass receive a work done, W. Okay, work done, W. Think about this. W. So W work done is, of course, force has a direction, displacement has a direction, but when it comes to work, so this is receiving only. Okay, for work we don't consider a direction. කාර්යයකට දිසාවක් නැහැ. I'm putting an arrow here because this work is being received by the mass. So that on that point, okay, on that point, I'm explaining. So as a result, yes, there are a lot of changes, including displacement, increasing of velocities, and change of momentum, whatever, even the kinetic energy level differences. Yeah, okay. Likewise. Now, let's say mass in dynamics, when receives a work, you have a little understanding what the dynamics, the change on the mass. You have an idea. Yes. When gas receives a work, okay, when gas receives a work, set of molecules are there, of course. When gas receives a work, as a result, what may happen? Okay, as a result, what may happen? Okay, I think you know this. You know this, and we have discussed it. I'm not going to complicate your views on this. Okay, but I feel we should talk about this as well. Okay. So what happens is when this receives a work, yeah, it affects pressure and volume. PV changed. Pressure and volume changed. So that's the point. Pressure and volume changed when the gas entity received the work. So the PV change is the reflection of the response of this gas entity when that gas entity receives the work. Okay. So you know, in the best example may be piston cylinder mechanism. So let me take a piston cylinder mechanism. Force. Force. Okay. So instead of force, we would say, let's say this received a work. Yes. By means of applying a force on the piston, it receives a work. Okay. It receives a work. So this gas entity receives a work. So there is a change of P and V. PV changing of PV. So that is the possibility. Okay, changing of PV is the possibility. Change of PV is the possibility. And so when force applied somehow, at this point, the work fully received here. Okay. So work fully received. So work, put it here. Yeah, force has been applied, and the force, there is a displacement of the piston. That's true, but this arrangement makes this work transfer to this gas or air entity. Oh, this is the work received by gas or air entity. Okay, work received by gas or air entity. So PV changed. Okay, PV changed. So here in a way that volume changed significantly, and even there could be pressure rising. Volume change and pressure rising because of this work done. You can see the PV change. Yeah. So when the gas delivers a work, means release a work. Okay, release a work. Same thing, don't worry. But worthy of drilling this. Now you are thinking like a gas. Gas is receiving this. Now it's different. Now it is different. Here, initially, it's pressurized in a smaller volume, but see, volume change, and this, because of this force, we can see the piston displaced with the force, so that this may do some work. Maybe when this pushes, there may be connecting rods and okay, now maybe cranks, so there may be some turning of flywheels, whatever, there can be a work done somehow because of this linear motion. So here what happens is, work. All released. Interesting. Okay. Work receiving, work releasing. Yeah. Work receiving, work releasing. Again, you can see the same. PV changed. Change of PN. So that's a possibility. So when gas entity receiving a work or releasing a work, there is a change of P and V. Okay. So here releasing, here receiving. Okay. Then in releasing of the work, you can see the volume increases, means the gas increasing, means we call it expansion. Prasarani in Sinhala we call it. Somehow there is an expansion of gas. Okay, so volume increase or expansion of gas entity is what we are observing when the gas entity performs work. Okay, yeah, it's quite simple. When a gas entity perform work, performs work, that is done by expanding the gas entity itself. Okay. So gas entity itself expands and performs a work. Performs a work means delivers. Okay, delivers or release a work. Delivers is the best, or the perform. Volume expands. Okay, so this is the obvious one. So you imagine the volume increase, but here when receives, yeah, it displays. So still connected with the space, receives a work, but somehow here is displaced when receives work. Okay, receives work. So we will come to receiving work afterward. Yeah? Now see, when a gas entity receives a work, receives, that is done by contracting, means a volume reducing, contracting, or the volume shrinking or reducing. Let's say in general. Yeah, because that's how they are receiving a work. So there is this contracting effect somehow. Contracting effect. Interesting, eh? Interesting. So here, when contract, receiving work means what happens is more energy gets stored. More energy get stored means energy level increase. Okay. More energy gets stored within the gas entity. Yes, this is what happens. More energy gets stored because it's a kind of energy input. So it receives, so more energy gets stored because it has to be there. if it received. Okay. And here, when this gas entity delivers a work, now gas entity has reduced energy. It has reduced energy. Lost its energy content. Okay. Lost. Not fully, somewhat lost. Energy content. I would say equivalent to W. Here also equivalent to W. Let's say no other heat interactions. Huh? So I put a question mark here. For some cases, if there are heat losses, it's a different case. Okay, but you can see that. So W receives. So corresponding there is energy rise. And if loss heat, there is a corresponding energy loss. It's a different story, but corresponding to W, there is an energy rise. Okay. Delivery, there is an energy loss equivalent to W. Okay. I believe you can digest this easily. Yes. Now, I'm taking the same. Let's say sometimes while receiving this work, even there can be gaining or losing of, let's say, losing of heat or gaining of heat. Let's say, put it. See, receiving some energy in this expansion process, heat. Okay, let's see. Now what happens? Yes. Sometimes there can be receiving of energy. Sometimes there can be losing of energy. If you think of losing, okay, mostly in the engines, you know, engine is very hot, releasing energy to the outside as cooling the engine. So, lost heat. So I mark this heat loss. It's a kind of energy loss, Q. Okay, I mark that heat loss, Q. So this is heat. Now it's a different story. Okay, it's a different story now. see both heat and work interactions. So lost its energy content equivalent to W. And also there is another portion of energy content lost equivalent to, give me a second, Bhutai. Now, I think I will do this way. Sorry, Bhutai, there is a little disturbing. Now, gas lost energy for work equivalent to W, and also lost energy because of the heat loss equivalent to Q. So two energy losses. Okay. So if originally the energy content E1, okay, E1, E1. and later become the energy content E2. Yes, then we can write an energy balance. Okay, energy balance. Energy balance. Writing an energy balance. Originally, it has E1. Okay. Lost W for work delivery. Lost some more for heat loss or releasing. And what finally remains is E2. Same like balancing money. Same like balancing materials. Okay. You can write energy balance like this. Why we can write energy balance? Because same like balancing money and all. So energy cannot be lost. It should be somewhere else. Also, energy cannot be created. If create, there can be more energy, no such thing. Energy cannot be lost, and also energy cannot be created. We call this conservation of energy principle, or we call this first law of thermodynamics. So that is the reason why we can write energy balance. Okay. So this is because of the first law of thermodynamics. Because, okay, the first law. Yeah. So according to this first law, we can write this. So how to know first law? You read your daily notes. Okay. Sorry, not the daily notes, the one-time note. You can have a better understanding. Okay. So this is just an expression. The engines, power stroke, you can have this. Okay. So this is the first law we are writing for a closed system. Initially, there is an energy content. And because of losing energy, because of work done and heat release, what finally remains is the initial energy content minus the heat and work, because heat and work also a form of energy in transition. So you minus this means the initial energy, heat and work all have the same energy units. Okay. I believe you can understand this. The same. So if this receives energy and work, let's see. Same way. Now receives work, see, W. So I change the arrow. So this gives it. And also do some work. Let's see. While gas entity receives the work, if there is a heat gain, let's say, I put gain, Q, okay, into the initial energy content, or into the gas entity, I'd say, heat gain Q. I will take this out. So the gas entity gains its energy content equivalent to Q. Yes. Now this is the story. Okay. This is the story now. Now you can write the energy balance. Interesting. I take E1 and E2. E1 and E2. Now you can see E1 receive some work and also receive some heat energy, thermal energy, and finally more energized results in first law of thermodynamics reflections. Okay. Interesting. Okay. This is very important. You feel this is very simple, but remember this is very important. And you should feel this rather than remember this. So again, energy balance. And this is a closed system. Remember this. And this boundary is moving because see, finally it's shrinked. So only one side fixed, all the three sides, the boundary changing. So this is moving boundary, but closed system. Closed in the sense, no mass goes out from here. For this process of receiving heat and work. Receiving heat and work, even in the suction. Sorry, not to the suction, the compression stroke. Yeah. So the flywheel effect anyway moves the piston inwards, but the cylinder is hot. So this sucked air, once being compressed, at the same time, the cylinder may be getting cold, but that air getting compressed may be receiving some little heat portion. Okay. Yeah, outside. Yes. Interesting. Okay. Interesting. The third one, I'm writing this way. If we think as a standard, the direction towards the system or the gas entity is the positive direction for heat receiving. This is the direction. Direction towards the system is the positive direction for work receiving. This is the direction. Okay. So this is for positive receiving of heat and energy. This is the energy balance, E1 plus W plus Q. Okay. Positive receiving heat energy. So later you can learn on this. So now you know this. Okay. And I will take only this one. This receives heat. And I'm taking this way, I'm writing this receives work. And finally results this. Okay, finally results this. Actually, I don't need this, don't need this, don't need this, don't need this, this. So this receives heat and work, and finally results this different status. Gas entity. That's what. Energy balance. Because only looking at the working fluid is enough. So initial state, before receiving heat and work, the final state here. Okay. Good. And what I will do is to make this little better. I will take I'll do the initial state like this. This is an intermediate taken place during the process. Okay. I put here Q. Q1 to 2